Nice to see you. So students, let us start with the next entrance module of the chapter rotational motion. In this module, we are going to discuss MCQs based on the concept of angular momentum and its conservation. Now students, we have all discussed law of conservation of angular momentum in the board's module. Do you remember? Yes, I hope so you have revised it. Yes? Very good. It's nice to hear that. So, can we start off with the module? Okay, let us take a look at the question. Oh yes, it's a very big question. Come on. Don't get scared. It's very simple. Alright, I am here to help you. First, let me read the question. A thin uniform disk of mass m and radius r is rotating in horizontal plane about an axis passing through its center and perpendicular to its plane with angular velocity omega. Fine. Another disk of the same dimension but of mass m by 4 is placed gently on the first disk coaxially. The angular speed of the system is. Alright, what are the options? Option A, 0.8 omega, option B, 1.25 omega, option C, 0.75 omega, and option D is 1.66 omega. Alright. Now students, it's a very big problem, don't worry. It's very simple. So, what is the procedure? Yes, the procedure is identify, set up, execute and evaluate. So let us move on to the solution. First step, identifying the problem. What are all is given there, students? Yes. First, a thin uniform disk of mass m and radius r. Now this disk is rotating about an axis passing through its center and perpendicular to its plane. Alright. And what is the angular velocity of this disk? The angular velocity of this disk is omega. So now, you see, can I write this? For the first disk, mass is m, radius is r, angular velocity is omega, and the moment of inertia of the first disk is I1. Alright, fine. What else is given, students? Now, another disk of the same dimension but of mass m upon 4 is placed gently on the first disk coaxially. Alright, so now they are keeping one more disk on top of the first disk. So I can write these things. For the second disk, mass will be different because the question it is said, mass is m upon 4. For disk 2, m dash is m upon 4. And what is the radius of the second disk? It is same. R dash will be r. And now, since mass has changed, what will happen to the moment of inertia of the second disk? That also will change. So let I2 be the moment of inertia of the second disk. Is that clear? Fine. What is asked, students? They are asking you to find out what is the angular speed of the system. Now both the disks are together and they're rotating together. They're asking you to find out what is the angular speed of the system. So they're asking what is omega system. Now, which formula can we use here? Yes, title of this module, conservation of angular momentum. Now here, nothing about the torque is mentioned, so the external torque acting on the system is 0. Then, initial momentum of the system is equal to final momentum. So I can write I1 omega equals to I dash omega system. I1 omega is the initial angular momentum of the system. Initially, only one disk was there. Now, I dash omega system is the final angular momentum of the system. Alright, so I1 omega is initial, I dash omega system is final. So using this formula, I can find out what is omega system. Now remember students, I dash is nothing but it is the total moment of inertia of both the disks. What is I dash? It is the total moment of inertia of both the disks. Why? Because now both the disks are together for final momentum. Exactly, a final angular momentum. Right. Now students, what is I? We need to know what is moment of inertia. Now here you see, the disk is rotating about an axis passing through its center and perpendicular to its plane. So we know, we have seen this in board module. Alright, the formula for the moment of inertia of a disk about an axis passing through center and perpendicular to its plane is mr square by 2. So this is the formula for moment of inertia. So we can find out what is I1, we can find out what is I2, as well as we can find out what is I dash using this formula. Is that clear till now? Fine. So let me move on and let us go on to the execution and evaluation part. First, what I'm going to do here is, see that I1 omega is equal to I dash omega system. Now what is the formula for moment of inertia? mr square by 2. Now take the first disk. For the first disk, mass is m, radius is r. Alright, angular velocity is omega. So now what will happen? I1 will become mr square by 2 into the angular velocity of the first disk is omega. This is the initial angular momentum equals to. See the final angular momentum. Final angular momentum is I dash into omega system. So we should know what is I dash. Now students, here I dash is I1 plus I2. Why? Because now both the discs are kept together. So the total moment of inertia is moment of inertia of the first disc plus moment of inertia of the second disc. So I can write that instead of I dash, I1 plus I2 into omega system. Now students, next I can write mr square by 2 into omega equals to. We know what is I1. I1 is mr square by 2. What is I2? You see that for the second disc, mass is m by 4. Only mass is changing. So I2 will become mr square by 8 because I1 is mr square by 2. I2 mass is only changing. Mass is becoming m by 4. So if you substitute mass as m by 4, you will get mr square by 8. So then into omega system. Is that clear? After this, it's very simple, students. You can easily solve it. If you solve this, you will get mr square by 2 into omega equals to, you add them. If you add them, you will get 10 mr square upon 16 into omega system. Now what we need to find? We need to find out what is omega system. So omega system is equal to, what are you getting? You will be getting mr square. You can cancel it out. If you cancel out mr square, you will be getting 16 upon 20 into omega. Now, what is 16 upon 20? If you divide, you will get omega system as 0.8 omega. Isn't this very simple? Just we have used the conservation of angular momentum. Alright, now let me bring back the question and cross check which is the correct option. Yes, you see there, option A is a correct option. So students, these types of questions are very, very important. But you see here, what did I do? I just took the formula. Initial angular momentum of the system is equal to final angular momentum of the system. Initially only one disk was there. The second case, both the disks were kept together. So moment of inertia will become I1 plus I2. Is that clear? So we'll be solving more such problems. So until then, I'll catch you up in the next module. Keep working, students. You can do it. I believe you can do it. Alright? So I'll meet you up. Take care. Rise and shine.